Hello, how you doing? AWS Lambda plus Amazon SQS. How does Simple Queue Service, also known as SQS, help you build distributed decoupled systems? Well, this is what I'm going to answer for you in this video. But first, what is SQS? Well, when you hear SQS, think giant queue in the cloud. Okay, let's get started. I'm going to quickly provide an overview of what we're going to cover in this video. First, I'll show you a diagram of the system I'm going to build. After that, I'll create an SQS queue and two Lambda functions. One for sending or putting a message into the queue, and one for receiving or getting messages from the queue. Next, I will test the system. Lastly, I'll summarize the key points you should take away in this video. Okay, let's get into it. In this video, I will build my system using two Lambda functions and one SQS queue. I will test my system by manually running the sending Lambda function, which will put a message in the queue. I will then show you that the receiving Lambda function will be triggered when that message goes into the queue, after which it will successfully read the message, then print out the contents to the execution console. Before I start building the system, I quickly want to share some key features of SQS queues. SQS has two types of queues. The first type of queue is standard. Standard queues guarantee messages will be delivered at least once, provide best effort ordering, and can sometimes deliver a message twice. Builders need to implement idempotent processing when using standard queues. Idempotent design involves creating systems that can handle duplicate messages without breaking the system. For example, if you get two duplicate messages requiring an insert into a downstream database, the processing should insert the record only once. Standard queues can scale to extremely high throughput, supporting near unlimited number of puts and get transactions per second. The second type of queue is a FIFO queue. FIFO standing for first in, first out. FIFO queues have less throughput than standard queues, but guarantee message ordering and one-time message delivery. For both standard and FIFO queues, they can be configured to persist messages for up to 14 days. Now, in the AWS console, I navigate over to Amazon SQS homepage. I click Create Queue. Let's create a new queue. I select the standard queue, and I enter a meaningful queue name. I click the Create Queue. Now I see the queue detail page. I click the Queues link to see the queue's summary page. I can now see my new queue at the queue summary page. Now I navigate over to the AWS Lambda homepage. I click the Manage Functions button. I am now at the Lambda function summary view. I click the Create Function button. Here, I provide a meaningful function name. I select Python 3.8 as my language runtime, and I click the Create Function button. I added my Python code. You can find this code at the GitHub URL shared in the YouTube description for this video. The Python code basically reads the message ID and message description from the event object passed into the Lambda handler. I put those two values into a JSON object, and then I put that JSON object into the queue. I'm going to quickly cover the Lambda configuration. I have two videos you can watch. One, creating Lambdas fast, and a second, AWS Lambdas plus IAM roles that show you step-by-step how to create Lambdas and customize the Lambdas roles permissions. Feel free to check these out if you want to see this at a more detailed level. In the interest of time, I'm going to keep going. I click the configuration link. In the Lambda configuration page, I click on the permissions link, and I click on the role associated with the Lambda. This gets me to the Lambda's IAM role homepage. I add the policy Amazon SQS full access to this role. Again, in the video, AWS Lambda plus IAM roles, I share in great detail how you can customize policies so you can give your Lambda functions exact permissions that they need. For this video, in the interest of time, I'm just going to give the Lambda full SQS access, but you wouldn't want to do this in a production system. After creating and configuring the first Lambda, I go back to the Lambda function summary page. Now I want to create my second receiving Lambda function, so I click Create Functions again. Again, I provide a meaningful function name. I select Python 3.8 as my language runtime. I click the Create Functions button. Now I have the second Lambda function. Now I want this Lambda to be triggered and executed when a message enters the SQS queue. To get this behavior, I click Add Trigger button. I now select the source. I click the down arrow to get a drop down of the source options. I click SQS as my source. I click the magnifying glass icon in the SQS queue edit box. My SQS queue shows up in the dropdown and I select it. Now my queue is selected. I entered 2 as a maximum concurrency. This is the maximum number of Lambda function instances that SQS can invoke at once. I now click the Add button. I now get back to my Lambda homepage. I can see that my Lambda function will be triggered when a message is put in the SQS queue. And this is exactly the behavior I want. Add in my Python code in the receiving Lambda function. At a very high level, the function gets the records value from the event object passed in. The records value is a list of individual records. Each record is a message that would be put in the queue earlier. I print out log messages to the execution console displaying the number of records I extracted from the event object. I then loop through the records list, and for each record, I extract the message ID and message description and print the respective values out to the execution console. Similar to the first Lambda function, I update the role associated with the Lambda function by adding the Amazon SQS full access policy. Before I test the system by manually running the first Lambda function, I have one more thing I need to do. So I click the test link. Here, I need to create the test event that will be passed into my first Lambda function when I manually run it. I click Create New Event. I give it a meaningful test event name. I keep the event as private. Lastly, I configure the event JSON so it has an attribute message ID with a value of 0001 and message description with a value of my first SQS test message. These two attributes will be part of the JSON passed into the event object when I manually run the first Lambda. Once my test event is created, I make it the default test event. I click the test button to run the Lambda. The Lambda succeeds. I put a message into the SQS queue. Now what? Well, remember, I configured the second Lambda function so that it will be triggered when the SQS queue gets a message. Since we just put a message into the SQS queue, the second Lambda should have been triggered and invoked. Let's go check it out. I go to the second receiving Lambda homepage. I click the monitor link so I can see the execution logs. I click the View CloudWatch Logs button. This takes me to Amazon CloudWatch homepage for the Lambda function log group. I now click the latest log stream link associated with this log group. Okay, and with this, I can now see the logs for the second receiving Lambda function. If you remember, the second Lambda function printed out some important information as it executed. I see the record count is 1. This is the count of records in the record list. Right? These are the number of messages in the queue. This makes sense. I see for the first record, the message ID is 0001. This also makes sense. I see the message description is my first SQS test message. This is what I would expect. If you remember, these last two attributes are the values we put into the test event. Okay, nice. It works as expected. Okay, so let's summarize what happened here. I manually invoked the first Lambda function, passed it my test event that I explicitly configured with a message ID and a message description value. The first Lambda put a message into the SQS queue. The SQS queue triggered the second Lambda function, passing the queue message into the second Lambda function's event object. The second Lambda looped through the list of records and printed out the respective message ID and message description values. I went to Amazon CloudWatch logs to see the logging history for the second Lambda function, and I confirmed everything worked as expected. Nice. Okay, so how does SQS help you build a distributed decoupled system? First, let's define what I mean by decoupled system. Decoupled systems are characterized by one or more subsystems working together without being directly connected. In a decoupled system architecture, software services have no or very little knowledge of other services in the system. In our example, the first Lambda didn't know about the second Lambda, and vice versa. So why are distributed decoupled systems desirable? The first reason is, since decoupled systems are broken into different independent subsystems, different teams can work on them independently of each other. In this model, each subsystem can have its own independent release schedule, giving the project a more overall flexibility. In a decoupled system, you can scale different subsystems independently of each other. In a decoupled system, using SQS, if one part of the system goes down, any unread messages in the queue continue to be persisted and can be read and processed as soon as the failed part of the system comes back online. This gives the system overall higher fault tolerance. In terms of system lifecycle, decoupled systems are more flexible and allow for quicker adaptation as business requirements change and evolve over time. So hopefully, you can see how Amazon SQS can help you build distributed decoupled systems and why this is so desirable. Okay, so let's summarize the key points in this video. Amazon Simple Queue Service, known as SQS, enables builders to build distributed decoupled systems. The architectural approach is desirable as it allows systems to be worked on by many individual teams. It increases project release flexibility, increases overall fault tolerance, and ultimately increases the ability for the system to evolve over time. Amazon SQS is fully managed. There are no servers to manage, no infrastructure to provision. Standard queues provide very high put-get transactions per second and guarantee all messages will be delivered at least once. All it does provide best effort ordering, and sometimes message will be delivered more than once. You need to build idempotent logic so you can handle duplicate messages with standard queues. If message ordering and one-time delivery are really important, you can use FIFO queues. The trade-off is put-get transactions per second or lower. Thanks for watching. All videos referenced will be in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm packaging up this content, please consider subscribing. And one last thing, we all love technology and we're excited about the innovation in the cloud and with machine learning and AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, move your body, and if you do, let me know in the comments. And with that, have a great day.